Here you have a zoomed in version of the kidneys and the blood supply to the kidneys. As I mentioned, here we have the abdominal aorta, and that abdominal aorta is going to, blood comes to the abdominal aorta from the same aorta that comes out of the left ventricle from the heart. And from that abdominal aorta, there's going to be a blood vessel, very important blood vessel called the renal artery. And that renal artery, right, which is going to supply blood to the kidneys, branches of that artery are what are going to be used for filtering, right? It's where blood is going to come from for filtering so that we can produce urine. And again, as you can see, the left a little bit higher than the right kidney. And whenever we make urine in what are called the nephrons, we have millions of nephrons in each kidney. That urine is going to come, it's going to come to the minor calyces, then to the major calyces, and it's going to end up in the pelvis. And from the pelvis, it's going to go down into the urethers that are going to go to the bladder. So how do we get to the renal artery? Well, that renal how do we get to the nephrons from the renal artery? And that is going to be done by, there are going to be, I'm actually not even going to ask you to learn those names. I'm just looking for my red. But just know that from that renal artery that comes into the kidneys, that renal artery is going to branch into smaller and smaller branches, right? Smaller branches. It should have been smaller. Ooh, I'm a horrible drawer. Anyway, smaller branches until at the end, we are not at the end, until we reach what is going to be called the afferent arteriole. That afferent arteriole is going to form what is going to be called, and it's going to be the glomerular capillaries. I'm going to show you what the glomerular capillaries are later. The glomerular capillaries. And then coming out of the glomerular capillaries, we are going to have what is going to be called the efferent arteriole, right? So we go from the renal artery to other renal artery to other smaller blood vessels. And then at some point, those are going to become the afferent arteriole. And from there, we're going to form the glomerular capillaries, which are going to be a brand. There are a network of capillaries. So there's going to be a lot of capillaries. We're going to see better pictures of this in a second. And then coming out of the glomerulus, we are going to have what is called the efferent arteriole. And then we're going to form what are going to be called other types of capillaries called the peritubular capillaries. That sequence of blood vessels is very important so that we can understand, because what we're going to do, where is my yellow? When we go from the renal artery to the smaller blood vessels to the afferent arteriole, and that forms a branch of capillaries similar than the capillaries that we had around the alveoli, right? But here, instead of diffusion of gases, we're going to be filtering, literally like if you were putting pasta to drain and you get water coming out of it, same thing. But what's going to be coming out is going to be, what's going to be coming out is going to be urine. Once that those peritubular capillaries, which are this one right here, those peritubular capillaries at the end, they are going to form what is called the renal vein. And the renal vein is what I said that was going to come back to, right? All that blood is going to be coming back through the renal vein that goes up to the inferior vena cava. And that renal vein is blue because in addition to that blood going to the kidney to be filtered, that blood is also going to be used to actually provide oxygen to the cells in the kidneys. So same as any other cells, they are going to be using the oxygen, releasing CO2, and that high CO2 concentration blood is what's coming out through the renal vein that needs to go up to the inferior vena cava and to the heart so that it can go to the lungs and get more oxygen and release that CO2. Here is a picture of the different glomerulus and a bunch of different nephrons and how they, at the end, that urine can go into this structure, and from here you can go right to the rest of this and out through the urethra. This is a pretty cool picture of those blood vessels and how they can branch into little ones that then are going to be forming the different glomerulus that you can see over here. We're going to see pictures of how that happens, right? We'll get into more details. This is another pretty picture. This is how what those capillaries look like. When we go, remember that we were going from, and I'm going to remind you this many times because it's important, right? We go from the renal artery to smaller little branches, and those branches at some point turn into the afferent arteriole. And we said that that afferent arteriole turns into this mesh of capillaries, right? Which is going to be called the glomerulus. These are a bunch of glomerulus, right? Here you have those capillaries right here, and you can see here the afferent turn into a glomerulus and then coming out the efferent, which is this, the afferent, the glomerulus, the efferent. Important is that that glomeruli, in plural, they are housed in a capsule. Right here, they had taken the capsules out to make that picture, but here you can see that there's a capsule. So you have the glomeruli in a little chamber, and there's a space between that capsule and the glomerulus. So what's going to happen is like the same, again, as I said, that you can strain pasta, you're going to be straining blood. And whatever can get out of those capillaries, it's going to be coming into this space. And from there, there's actually a tube that is going to be called, we're going to talk about it in a second. There's going to be a tube that's going to be collecting all that urine. We'll see that in a little bit. And then that efferent arteriole turns into what are called peritubular capillaries. That's going to be a little bit later. We'll see the details on that. Let's talk about that nephron, right? We said that we have the afferent, we have the glomerular capillaries, and we have the efferent. And I just said that on top or around that, those glomeruli, we have a little capsule, right? And that capsule, I said, that has a tube that comes out of it. Well, that capsule is called the Bowman's capsule. This right here is called Bowman's capsule. And Bowman's capsules, as I said, is going to collect the urine that we are going to be, the filtrate that is going to be coming out of straining that blood. And that filtrate is going to be able to continue down that tube. Let me go back to black. That tube, right, it's going to, that tube is going to be called the renal tubule, like a little tube, right? And that renal tubule, it's going to have different sections. We're going to have what is called the proximal tubule, then a loop, and then we're going to have a distal tubule. Okay, so that tube at the beginning is going to have a proximal tubule, right? Then it's going to have what I said, it's going to be called a loop. A loop, 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 loop. And then there's going to be a distal tubule. Okay, so this is the proximal, it's close. Then the loop, it looks like a loop. And then the distal is the one that is far away from that capsule. And again, all we're doing is sending this filtrate, this yellow filtrate, sending it all the way that way. And let's take a look at a picture of it, better than mine, right? Here we have, as we said, the afferent blood coming from the renal artery, then forms this mesh of capillaries called the glomerulus, and blood comes out called the afferent arteriole. Afferent going in, efferent coming out. That filtrate, there's a capsule, Bowman's capsule, that's going to collect all that filtrate, and that filtrate goes into this tube. And there are different sections. We have the proximal tubule, which is going to be close to the glomerulus. Then we have the loop. It looks like a little loop. And we have what is called the distal tubule, which is the one that's further away from the glomerulus. So proximal tubule, nephron loop, distal tubule, and that distal tubule ends up in this big thing called the collecting duct. Actually, there's going to be a bunch of different nephrons that put in, urine or that filtrate into the collecting duct. And let me show you that here you can see collecting ducts. Right here you can see a bunch of different nephrons putting all their filtrate into this, which are going to be those collecting ducts that at the end are going to end up in those smaller minor calyces and then major calyces. Another look at the nephron. Another look at the Bowman's capsule with the glomerulus. Again, afferent arteriole coming from the renal artery. That afferent turns into a bunch of capillaries. It makes smaller and smaller capillaries. And then those capillaries come together and form the efferent arteriole. Important to see, both of them painted red, because when we go into the glomerulus, we are not doing that gas exchange. The only reason why blood is going into the glomerulus is to get filtrated. It's not to do gas exchange. That's done in different arterioles in the kidney. Important to see here, and the reason for this picture on the right. These capillaries, as you can see, have these coverings that are called podocytes. And podocytes are these cells that are going to be forming attached to those capillaries. And those podocytes, they're called podocytes because that's coming from feet. They have these extensions. So here's a podocyte. So all of this is a podocyte. And that podocyte has these branches. And what happens is that wherever the podocyte is, nothing can be filtered out. But in these gaps that we have between the feet of the podocyte, we can actually filter things out of the blood. So imagine in that strainer, the podocyte is the strainer that doesn't allow things to get out that are too big. For example, you're straining pasta. If the holes in your strainer are too big, pasta is going to fall through. But your strainer has small enough holes that you filter out water, but not pasta. That happens with the podocytes. The podocytes have little holes, but those holes are small enough to allow some things to go through, but they don't allow red blood cells to go through. They don't allow proteins to go through. They don't allow anything that's big in your blood cannot go through. That's why it's not normal to have blood in your urine, because red blood cells don't get out of, they cannot fit. Those red blood cells are like that big. They cannot fit through the podocyte, through the slits of the podocyte. But water is small enough that can fit. Glucose is actually too big to filter, so it's not normal to have glucose. Well, actually, it can fit. It's just that it gets reabsorbed later. Not important. Don't learn that yet. We'll get there in a second. Another picture, maybe a little bit simpler. Again, where is your afferent? Let's find your afferent. if this is the efferent, this is the afferent right here. Afferent arteriole, and you can see it because it has that arrow. Blood goes in. This is what the glomerulus is going to look like, those little capillaries. Blood comes out, still oxygen rich. All we did here is filter out whatever was small enough to fit through the podocytes, and whatever didn't filter out, it's going to continue here. And we said that the efferent turns into peritubular capillaries. Now, why is that important? Well, there are different things that can happen to things in the blood. There are three things. One is going to be filtration. So filtration is it's what happens here. Filtration is moving things out of the blood into the tubule at the glomerulus. Then we can have something called secretion. Secretion is later that peritubular capillary. We can actually actively secrete things into the tubule that are also going to end up in the urine. And then the third thing is called absorption or reabsorption. Normally it's called reabsorption. And reabsorption is anything that you filtered out that you want to keep, you send back to the peritubular capillaries. So that's why they're important. So this is reabsorption. Reabsorption is reabsorbing back into the blood. Secretion is sending to the blood after filtration. Normally for secretion, you need an actual transporter in the membrane to be able to do that. And this is just filtration, which is just done by physics. It's high pressure. It comes out. Normally that hydrostatic pressure is very high. I think we cover that in a little bit. And that's why you can send water out of the glomerulus into the filtrate. Here is a summary. We have that we can form that urine because from the glomerulus, we are going to filtrate, right? And that is going to go from the capsule to the proximal tubule. Then it goes to the loop. Then it goes to, important, I didn't mention that. There's always that little loop, right? We have the proximal convoluted, or the proximal tubule. And here we have the distal tubule. And this is the loop. The loop actually has a descending, going down, and an ascending, going up, part of it. So blood goes from the glomerulus to the proximal tubule, to the descending, to the ascending, to the distal tubule. You can see it here. We have blood going from the proximal tubule, filtrate going from the proximal tubule to the descending, to the ascending, to the distal tubule, to the collecting duct. We can see it here. Blood goes from the glomerulus to the proximal tubule, to the descending loop, to the ascending loop, to the distal tubule, to the collecting duct, to the minor calyx, to the major calyx. So we go from the glomerulus to the capsule, to the proximal tubule, to the loop, descending first, ascending second, to the distal tubule, to the collecting duct, minor and major calyx, renal pelvis. Now we're out of the kidney, urethra, urinary bladder, urethra. Very important, this sequence. We've talked about it, but it's very important. We're going to stop here and we'll continue on the next video.